All right, so let's look at some basic formula problems and probability before we go into theoretical probability and empirical probability. So this is question one, which says, if a perfect die is cast, what is the probability of obtaining a 5? So normally when I work with my students, I tell them that understanding word problems, understanding the question, representing it out accordingly is one of the keys to be able to solving word problems. Okay, so for this one, we already know that it says a perfect die. So we already know the sample space of a perfect die is 1, 2, 3, 4, 5, and then 6. Now they want us to find the probability of obtaining 5. So this is 5 in a perfect die. Now the chances of getting 5 when you throw a die is actually just 1. So this is one chance over chance of getting everything 3, 4, 5, and 6 over the all the possibilities. So that is just 1 over 6. Okay, so this is easy to understand. So without even doing this part here, you already know that it is 1 over 6 because it's just the possibility of throwing one dice. You get only a possibility of getting 5 just once, so it's 1 over 6. So I think that's clear. Now, what about this question? If there are 22 boys in a class and 18 girls, if a student is chosen at random, what's the probability that this student is a girl? Okay, so this question, you still need to understand the formula. Please remember, okay, I didn't mention it in the last question. The probability formula, as usual, is the number of required outcomes over the possible outcomes, total possible outcomes, okay, over the total possible outcome. All right, so let's just establish that again. Now, the question mentions that there are 20. So the question shows that there are 22 boys in a class and 18 girls. And now, for us to be able to find the probability of choosing a girl from the class, just come to the class, you want to pick a girl from the class, the total population of the class, or the total possible outcome, is the total population, which is actually, this is the total possible outcome, is 22 plus 18. So that's the total population in the class, and which is actually 40. Now, the chances of bringing a girl out of the class, you actually can pick from any one of the 18 girls. So the chances has to be 18 out of 40 um, in terms of probability. And when you read it to the lowest term, you see it becomes even clearer. So um, following the formula, number of required outcome over total possible outcome. So the required outcome is in terms of girl. And since we do not know the actual girl, did not tell us probability of bringing Jane out of the class, probability of bringing Riley or anything. They just told us the probability of bringing a girl out of the class, picking a student that's a girl out of the class. So we could pick any one of those 18 girls out of the 40 students in the class. And so this is the probability of picking a girl from the class. All right. Now, what of this question? A bag contains 9 identical balls, out of which 3 are blue, 2 are white, and the remaining are red. If a ball is drawn from the bag, what is the probability that it is blue and B, not red? So let's start with the first one. We need to understand the question. It says that there are 9 identical balls. So total number of balls, um, 9 balls. So we have 9 identical balls. Now it says that we have 3 blue. So number of blue, we'll say 3. Um, we have 2 white. So number of white, we'll say there are 2. And then the remaining are red. So since there are 9 balls, the remaining will be actually, we already have 5 here. So the remaining should be 4. So the number of red, since they did not give us, we'll just do that by ourselves. That would be 4. Okay, I'm sure you understand how we got 4 because we have 5 balls complete here, and since there are a total of 9 balls, the remaining number should be 4 for red. That's it. Now, if a ball is drawn from the bag, what is the probability that it's a blue ball? If we have to bring out a ball from the bag, and they want us to find the probability that the ball we bring out of the bag is blue, we have to look at the number of required outcome. So the possibility that we can bring out blue from the bag, we can bring any of the blues in the bag because there are actually three blues in the bag. So the probability has to be three out of the total number of balls in the bag, which is nine. So this is the probability of bringing out. So let me put this properly well. So when you want to solve this, you can say that the probability of bringing out blue from the bag is 3 over 9. Now the reason is because this is just the chances that we can bring any one of the three blue balls in the bag, and then we can bring that out of the whole nine balls in the bag. Um, that is This is the answer. And when you reduce to the lowest term, you see the answer is 1 over 3. So this is the chance of bringing out a blue ball out of the bag. All right. So we've seen that following the formula, number of required outcome over total possible outcome, we understand that the one up is always the number of required outcome, and the one down is the total possible outcome. Okay. Now, but this second part, what is probability that it is not red? I'm sure you remember very clearly that when we solved, we did the theory aspect of probability. We discussed the formula of finding the red. I mean, finding them. What do you call it? Um, my brain is knocking now. Okay, we discussed the theory that shows when something is not happening and when something happens. So probability of failure and success. And we gave this formula that the probability of failure plus success equals to 1. You say probability of success plus probability of failure is equal to 1. And we said the probability of failure is equal to 1 minus probability of success, if you remember that very clearly. So the probability of failure is actually the probability of something not happening. So that's the formula we're going to use for not red. And the probability of success is the probability that the event happened. So the probability of success is the probability that we got red, you know? So we're going to say probability of us not getting red. Um, Let me clean this out because I don't have space. That's why I'm doing this. Probability of us not getting red. Probability of not red um, is equal to 1 minus probability of getting red. That's the idea. So what's the probability of getting red? We already know that red, let me put that here. We already know that the number of red is 4 from what we discussed before. And the probability of getting red um, has to be um, picking, bringing out red has to be bringing out any one of the 4 red balls out of the 9 balls. So this is the probability of picking out red here. Okay. So we already know this. Now putting this into the equation, we have equal to 1 minus this probability of getting red, which is going to be 4 over 9. So 1 minus 4 over 9. And this will give us what? Okay, this will give us 5 over 9. All right, so that's the answer. So